Hello, I'm Mehmet Arda Yıldırım from Bilkent University Physics Department, and this is my Physics 211 Waves and Optics project video presentation. In this project, we investigated the birefringence of a single-layer bob tape using Arduino Uno for automated data acquisition from a cross-polarizer setup and Mathematica for sinusoidal fitting and uncertainty analysis, while multilayer orientation is simulated in ANSYS Zemax Optics Studio for further understanding.
Utilizing Jones' formalism to work out the falling beam theoretically, we expect to see a sinusoidal trend. More specifically, the intensity is proportional to the sine squared of 2 times the rotation angle. Once the intensity function is fit in Mathematica, the retardance value can be found, from which the birefringes can be computed. The optical table in this experimental setup consists of 2 linear polarizers placed in cross orientation, and a birefringent material in between, which is a simple commercial bob tape, placed with a stepper motor. At the end is a photodiode measuring the intensity of the transmitted beam. As the stepper motor rotates the tape along the optical axis in 5-degree steps, the photodiode records the intensity data with the angular rotation data. Having acquired data from 14 rotations, the intensity data is fit to the sinusoidal trend expected, where A, B, and C respectively correspond to ambient irradiance, the term involving intensity with retardance, and lastly the shift due to non-perfect initial placement of the tape to stepper motor. Removing the second filter and running the setup again for 3 rotations, the proportionality constant I0 is averaged from the data. Using the derived formula for birefringence, we obtain the following value with the following uncertainty. In ANSYS Zemax Optics Studio, the exact setup is simulated except for thickness of the birefringent material, which is taken variable to observe the effects of thickness on transmission rate in bob, since the defects accumulate practically and deviate the data significantly for multilayer tapes. The simulation results suggest that the tape we used has a decent transmission rate, which makes it suitable for a waveplate material. Also, we could see what other thicknesses have better transmission rates, like 4 layers of bob tape having a higher transmission rate than 1 layer. The experimental and computational data we gathered demonstrated the theoretical expectations qualitatively and produced reasonable quantitative results.